Alright, what's up everyone? This is Code Jam Round 1A, 2022. I need to get top 1500 in this round to advance on to round 2, so that's what I'm hoping for today. And it starts in about 10 seconds, so without further ado, if you're competing as well, good luck. Alright, let's see how this goes. Alright, need to refresh. Right, double or one thing. You're given a string of uppercase English letters. You can highlight any number, possibly all or none of them. Not be consecutive. Okay. Obtained as a result of the process depending on given a string. Up the one that appears first in alphabetical known as lexicographic order. Okay, so we want to output. Oh, we want to output the lexicographic smallest possible way. Okay, double or one thing. Sample 2 is a hidden verdict. Double. I have a feeling for this problem, you could, like, you either, like, okay, let me first just read in the input. Okay, that's the input. If all the same. So, for example, if you had AA, is AAA graphically smaller? F is a prefix of T. Okay, so if all the same, do nothing. What if AB, then AAB is better? What if BA, then do nothing. Because BA and like BAA is some. We never want to like double like the last block, so we can consider these in blocks. We never want to double this last block. Never double the last block, because then, like, if we don't double it, it's just a prefix of that, and it's always smaller. Okay. Prefix is always smaller. I think it's something to do with like ascents and descents. Yeah. Something like that. Car prev is equal to array of 0. Or I guess if array at I minus 1 is not equal to array at I, let's not add array at I. So these just like account for like which blocks are like doubled and which ones are not. Okay. So you want to double a block if you want to double a block if it's like going from down to up. Yeah, because if it was like ABC, we always want to turn this to AABC. We always want to turn this to AABBCC. Or AABBC, yeah. Okay. Tar curve is equal to array of 0. Okay. Array I is equal to curve. this is when we're transitioning to new block. If curve is strictly less than array at I. Okay. Then size gets doubled by 2. Curve becomes array at I, size becomes 1. Alright, let's test this problem out. Peel. Oh, right. Because you still need to like append the last block, yeah. Okay, that looks correct. Java solution. Alright, that should be O in time, so I think if it passes a small test case, we'll be okay. Equals sum, and then, yeah. And then task. Okay, we got the small one. I think it's probably okay then, because it's O event time. You're given a set of distinct integers. You separate them into two non-empty sets so that each integer belongs to exactly one of them. The sum of all elements of the subset is the same. In a non-empty set tool, the problem above is unlikely to be solved in polynomial time. Then you decide what half of the integers are. Okay, so distinct integers are given another integers are distinct from each other and from the ones you chose in phase 1. You have to partition these integers into two subsets both of which sum the same amount. All two integers are between this and this. Guarantee they sum to an even number. N is equal to 100. This. BI does not equal to this in BI. You have to output and distinct integers. And in this case it's 100. Okay. Following prescribed drinks of a series of exercises to order each exercise requires W times weights for exercise may require 3 weights of type A and 1 weight of type B. Any order they place at the bottom. Test case number Y is middle number stack operating to run through all exercises. Recognize number types of weights. Weight types are 1 W and E as follow. I confuse W integers. This related ith exercise requires exactly this many times. Up to 100. Here's this 3. This has 3 in here. I think I'll do the easiest task. This one. We've got Okay, I suspect that the relative order is always the same. So for each 10 exercises, you just want to brute force. Which one is like the best one to do? Well, if you need to remove something, you need to keep on removing it. Yeah. And then you add on those weights. Oh, not necessarily though. Oh, but the sum of this is almost that, so you could just bit mask it, probably, right? Yeah. It literally just uses like a state search or whatever. Should I do this? Not sure as a subtask I should do if I think about this a little more. I want to think about this just a little bit more since this is not trivial implementation. Okay, but this basically means that it's always possible if you fix if you decide which half of these integers are. Okay, well in this case it's given that n is equal to 100. I think it might come down to speed forces on this problem, so I might actually just start implementing this. So for each exercise we need we need to maintain like what the actual state is. Yeah. This is at most 200-ish. Actually 150. People see is almost 3. Or actually we could just do something that's like could we just do Floyd Warshall maybe? No, BFS is probably just better. The distance of our negative one. So if we do something that's like q.add get at I, distance get at I, get at I is equal to 0. return 0. Public static and add a key, and this is a digit. Okay, so that's like the BFS. So cur. So if dist from here to next, if this is equal to -1, then this quantity becomes dist add number if d plus, okay, well, if cur is less than 100, yeah, it doesn't matter which order of a state we actually go in. We do if this is at most 3, and add cur d, yeah. Wait, this doesn't account for the case if there's like 0 of one thing and like more than one of that. Remove is okay. Yeah, remove is okay because they're just like remove. Or I guess we need to remove any one of these numbers, or we need to add on any one of these numbers. Yeah, okay, that might be a bit of a problem. Yikes. Cur minus cur mod 10. Or I guess it's just like whatever digit it is. Cur mod m. Temp over m. Temp gets modded by m. This is just like a digit itself. Yeah, this is like the digit itself that we need to remove. Maybe not. What is like a best way to do this? um. Hmm. Static final infinity. Maybe you just do the fluid partial. I feel like it might actually be the easiest option. Lamau just like iterates over all the possible digits. Because you either need to remove one weight or add one weight. Yeah, I think this might be better. Maybe you just ignore all of these methods that we wrote because they don't account for like gaps in between. If A is, okay, so remove if A is greater than 0. And then obviously distance at R to R is equal to 0. Distance at this is equal to 1. Distance at val minus 10 is equal to 1. Distance at val minus 1 is equal to 1. Add if A is less than 3. Oh, we potentially add a weight one. So we do distance at val plus 100 is equal to 1. If B is less than 3, distance at val plus 10. If C is less than 3, distance at val plus 1 is equal to 1. Okay, and then we do when x is equal to 0, x is also 150. When y0, y is also 150. The distance from x to y, min at distance x to y, distance at x to b plus distance at b to y. And because we use this as a max value, it should never actually overflow. Okay, cool. And so we have for each value, we just have the state that it's used with. So dp is equal to new int. It's almost 150 states. Infinity are just impossible states. This is obviously a possible state, and it takes 0 moves to get there. So we do E and then W. What is W again? Oh, number of possible weights, right? What do we do for this? Okay, so we do that. Read array is not in this file. Sag. Now it is. I equals W minus 1. I agree. Okay, how should I actually like label these? Because maybe I should just do them like, or consider them from like the first one being the largest, or first one being the smallest, I mean. I feel like that's probably better. I think it's still correct if we do that. What exactly are we doing here though? Oh, we're generating a key. Generating a possible keys. We know the frequency. Do we also know the order itself? I don't think so. I don't think we know the order itself. No, we also need to store the order itself then, right? Yeah, we also need to store the order itself. It's like 10 factorial over 6 times 6 times 6. There's about this many. Yeah, we would need the order itself. No, but this relies on the fact that same weights should try to stay together. No, but like if after some removal, it's not necessarily true though, right? It's not necessarily true. It is not necessarily true. Yeah, this is not working. I screwed up. Oh, I screwed up big time. We wasted we wasted quite a bit of time on that. I think I can still try to recover from this though. Cause I can use an array to represent, or like even a string would probably work. You just take a string to represent it, and then for each string, I want to make a new file. Let's delete these comments as well, because they're not really necessary. I don't need any of this either, because this is wrong. It's so unlucky. DP. I think we still need this DP, just like represented in a different way. So instead we need a hash map of all the possible strings, I guess. They need me any order, but like that's the order itself. What is 10 factorial by itself? Is it, how big is this? 3 million. Okay, so generate all possible strings. We need to generate all possible strings. So what do we do here? I guess it's something like a BFS, right? Yeah. Yeah, we could do like ABC. Doesn't really matter exactly. Q.add. Well, each thing appears at most. this is just equal to the same thing over here. So for int, yeah, because it's almost 3. So patterns add cur plus lol, q add cur plus lol. Lol adds on c. Okay, cool. So patterns tells us all possible strings. Yeah, but we also need to account for empty spaces. Already started, so I might as well just finish this. Lay is equal to layer dot whole. Yeah, this tells us the next string to consider, basically. And there could be duplicates, but there aren't that many duplicates, so it's okay. I can actually replace array with attach set and it'll probably be okay. Lay is equal to layer dot poll. Instead of using this, we just use lay plus 1 plus this. Or I guess next is equal to lay plus 1. Yeah. Or I guess just lay. Yeah, just lay. Yeah, so just let's just see all the next. Fucking hell. Okay. I know cur is obviously a thing. Well, here add cur, layer add next plus 1, I don't know. Yeah. Patterns add, q add, layer add, next plus 1. Okay, I think this is correct now. Like this gives a correct form of strings. One test case we do. Let's say we have up to 10 exercises, doesn't matter, but weight is up to 3. Are you sure? That does not look right. I highly doubt that's correct. I didn't fucking scramble them. Oh my god, I'm gonna have a stroke, aren't I? I'm having a stroke. I keep on forgetting to account for the different order. this is not a trivial brute force. I'm having a stroke. Anyways, how do we do this? Maybe do something along the lines of not being a dumbass. Okay, what if I'm thinking about this one? I'm gonna think about this one properly. I'm gonna think about this problem properly. Equal sums. Oh yeah, right. I already understand the problem. It's just like you have to find a partition. Yeah, you start with 1 through 5. 10, 4, 9. Yeah. So the set of numbers we print is always going to be fixed. Let's read a line containing a single number n. Up a line containing n distinct numbers. Like, what if n was equal? What if n was small? Like, n was equal to. I mean, not like super small. But n was equal to like 6. It's like one thing we could do. I'm going to choose bi such that the sum of all 2 n integers is even. How do we guarantee that the solution will always exist then? Is that something we can even guarantee? Because let's say if we choose like the first 100 numbers, for example, 100 times 101 over 2. That's definitely too small. So we need the sum of. Yeah, one thing to notice is like we need the sum of all of the numbers that we choose to be greater than 10 to the power of 9. Because if they're smaller than 10 to the power of 9, they can just choose 10 to the power of 9 and like any other number of digits. Those 10 to the power of 9s could. Or I guess the thing is, like, we know what the sum of this is. We also know what these integers are. Yeah. And I get it, like, half of the integers are. They have to be distinct. What if we do something with powers of 2? Okay, if we did something with powers of 2, the most it can be is 10 to the power of 9. However, we would need to be able to. Okay, the maximum sum this could be is like 10 to the power of 9 times. What is the max sum this would be? It's called equal sum. I guess a test case thing isn't really a thing anymore. Number of test cases, okay. It's roughly this, so it's 3. It's like 99 million-ish. Like roughly 10 to the power of 11. If we can choose all of these integers to be distinct, so that, because 10 to the power of 11, what is the largest power of 2 that's smaller than it? Is it 32? Or is it like 40? No, not, probably not 40, maybe 37. 36, isn't it? .36 is up biggest. Okay. If there is a way that we can represent, that it's possible to separate all powers of 2 in here, then it's always possible. It doesn't matter what these are, just take a sum of these numbers and then just like represent it in this bit form. So, question is, how on earth do we do that? 2 to the power of 0 to 2 to the power, because like the values themselves can be at most 10 to the power of 9. So we can do 2 to the power of 29 easy. 2 to the power of 30 to 2 to the power of 36. How do we do this? Cool. Integers, because these do have to be less than integers. So we do this, where b is equal to 31 or 30. We need to find some set of like 3 numbers such that this works. How do we find this? Yeah, this is not extremely obvious because all of these numbers have to be less than or equal to 10 to the power of 9. It's up to 37. I'm going to use 30 to 37 here. I'm going to call 30 to 36. Yeah. How do we do this? Like literally, if we can find this number set, like we need to find 30 through 36, and we have at most, we've already used 30 numbers. We have 70 numbers left at our disposal. We have 70 numbers left at our disposal. Is this even possible? First of all, like this 2 power 36, like 2 power 10 to the power 11. We would need 100 numbers alone from that to get this bit. Wait, is it even possible? I guess that's the sum of all of the numbers, but we only need sums for half. If we only need sums for half, then we only need to consider it up to 35. Yeah, sum of the 2, like 35 should be enough. Yeah, so maybe only 35 is necessary. That might help a little bit. But even then, how do we do this? How can we find that 35 is, like 2 to the power of 35 is still huge. Because each number can be approximately about 10 to the power of 9. So if we divide this by this, it's about like 50-ish numbers probably, or 34, 35. So let's say like 50 numbers. We need 50 numbers for this. We need about 50 numbers for that. We need about 20 numbers for that. It like gets cut in half, and so it's like, so 50 and then 20 and then whatever. are some ways we can skip bits. Yeah, the problem is like this alone would probably not be like, this would probably not fit in here. That would most likely not fit. And like, it's not even obvious how you even find numbers that satisfy this property. But we don't need too many in that regard. Oh, also the sum itself is bounded slightly. Because we do need a collection of numbers I can like set to 30, 31, 32, but like the sum in itself is only up to 2 to the power 35. Or 2 to the power 36 minus 1. So it's actually slightly smaller. I don't think it's smaller enough though. Like a total sum, but like the actual thing we need to represent is the most that. 2 to the power 35 minus 1. So we really only need 2 to the power 34 digits. Okay, that helps a little bit, I think. Only use 30 and 34 here. These are easy. For power of 30, something we should do is equal to new array list of like 35. So we do this. While sum is greater than or equal to. While use not contain, then we just use use dot contain sum. Sad. Otherwise, we do bucket to b dot add and sum. Oh, it's not sad. More importantly though, how many integers are there? Oh, okay, we solved it. Okay, we got this problem. Okay, this works, this works, this works, this works, this works, this works, this works. Okay, this works, this works. Oh, scythe. Let's go. Okay, this works, this works. Hey, yo, this is a working solution. X used ls dot add x while ls dot size is less than 100. We do, what do we do here? Oh, we won't actually use ls over here. While ls size is less than 100, we do curve decreases. ls.add curve minus. Yeah, ls.add curve minus. Cool. And so okay, so equal sum. So what we do over here is we output these numbers. String builder SB is equal to new string builder. String builder and then we read in these numbers. Long sum is equal to 0. For an xls, sum plus equal to x. We read in an array. We do this. Oh, I actually do need to read in an array. Lol. For int for integer I is equal to x an array, sum plus equal to x. Long target is equal to sum over 2. What we do over here now is we do something along the lines of this. Array list integer target element of b is greater than 0. B is less than the size of a bucket we care about is at most 35. If target element of b is greater than 0, for invalid buckets at b, res.add val. Res.get at 0 for an I is equal to 1, I is less than res.size, I plus plus, and 0 append. Do I have to do anything else for this? I'm just going to try submitting this. Solution. Let me just make sure I didn't accidentally print something here. I'm just gonna get rid of comments here. Runtime error. Really? Okay, hold on. How is that happening? What do I just run this code? Let's do one test case and 100. Is a little much. I think 100 is a little much. I just realized that 100 is slightly much. But the size of this list is 100. Yeah. Okay. Okay. N is always 100. If N is always 100, then something we can do over here. They're going to be positive integers, right? Yeah. Answer I got a rest, I got 0. Shit. 30. That might be why. That might be why, actually. That actually might be why. Fuck. Fuck. Hold on. Why is this the wrong answer? Oh, this is so hard. This is so annoying to debug, though. Static buckets. I don't like this. I don't like this. Am I using ls in here? No, literally, I'm just printing the string a bunch of times. Okay, so I'm gonna return string preprocess. Whatever. There's like no input. I'm just getting all of this code over here. Just putting it in here just because it's easier to read. And then also static array deck buckets. Boom. String long is equal to. Preprocess. Initial sum is equal to 0L. So it's equal to preprocess. Long sum is equal to initial sum. Array list, initial sum. I think I actually need 35. Why is this taking so long? What did I do to make this take so long? Hold on. Okay, so we're done here. We're done here. Oh, I'm stupid. There we go. Lamau and this. It's not big enough. Okay, we also need 30. We also need 35. So 36, and I might need something bigger than that actually. Do we though? Wait, actually, if you can cover 35, will it be enough? If we cover 35. Shit. The size of this thing is getting too big. What if you process 35? What if you process it in a different bucket order? I don't know if that will actually help or not though. No, it doesn't. How big is it? It's off by 2. Oh, that hurts. Oh, that hurts so much. Ew. Wait, that's so annoying. Wait, hold on. Bruh, please. Like, this is... Hold on. N is equal to 100, so just sum of all 2n integers is even. How do I... I'm so confused. Wait. What if we limit the sum? But even then, the sum could be up to about, like, whatever this quantity was. When it was like... ten to the power 11 minus this. That's the biggest this could be. Or something like that. Which is not good. Why is this not working? We're going to use this. Oh, wait. Do you not necessarily have to find a solution? The solution gets all cases right. Judge could have given the solutions for first test case, make an impossible solution to find a valid partition and stuff that's an equal sum. So, okay, are we, but like we're supposed to provide a test case so that it's possible for any of them, right? Yeah, so roughly 2 to the power 35. Not this. This. Yeah, but the value that we would need is way too big. Because this means that we need to multiply by about 5, which means we would need at least up to 37. But 37 is already too big. Because it's 100, it's 2 to the power 7 times 2 to the power 30, which would mean we would need already about 2 to the power 7 of those things, which is over 100, and n is 100 in itself, so I don't think it's actually possible. To the point where, like, even if we ignore some of the numbers we provide, numbers already given could violate that. Maybe we need to choose numbers such a way so that we can also use numbers from the second set. That's probably what we need to do. We need to be able to choose numbers from the second set. So, in other words, we would choose numbers, for example, if we process them greedily. Then it would have to work in that way. Yeah. I think it would have to work in that way. Three to the power of this. Numbers can also be represented in the powers of 3. Maybe, what if we use powers of 3 instead? Or even powers of 10. No, but then it's like, even the sum could be up to like 10 to the power of 11. We would need like, I mean, we only need 10 numbers then. Huh. Powers of 10 maybe? Powers of 10. Would that work? Powers of 10 maybe it might be able to work here. It's just that we would only we have to generate like 10 to the power 9, and then we have to go from 10 to the power of 10, and then like 10 to the power of 11. That's not that many. Okay. That might actually be a lot better. Equal sum 2. So what if I just like delete all this? Because the sum itself can only be at the very, very most 10 to the power of 11. Is equal to while sum is while use that contains cur bucket.add per for an xn used we do ls these are numbers used to fill that 10 to the power of 10. So while offset size is less than 100, okay, cool. And as always, no, wait, that doesn't work though. I'm so dumb. Wait, that clearly doesn't work because we're making multiple copies of these. And they have to be distinct as well, so we can't duplicate it. That's why I use powers of 2. god, today's not my day. Today is not my day. Oh my god. Wait, n is always 100. So yeah, because we need powers 2, then we just like use that power 2. It's like you either use it or you don't use it. But the problem is like 10 to the power 11 is too big of a power of 2. To the point where like you can't even represent it with 200 numbers. Yeah, because the target sum itself could be about 10 to the power of 11. Like, that's just too big, so you can't think in powers of 2. That's probably not the correct solution then. That can't be. There's no way that's the correct solution. It's impossible for it to be. All 2 n integers are between 1 and 10. All 2 n integers are between 1 and 10 to the power 9, inclusive guarantee is similar to an even number. How is that's not possible though? Wait, no, it is. No. 2 powers of 2 is not possible. How else would you do this though? Like, how else would you easily like be able to generate the sum? What? Oh. Are we sure this is possible? Because it's like, if we have some number here, so let's say this number is 11. I just don't think this is possible. Like, are we supposed to print when a solution doesn't? Are we supposed to print when a solution doesn't exist, or is it always guaranteed a solution exists? Solution. I'm assuming it has to be done in a way so that it's always possible to get it. Maybe you can use numbers in here that happen to be big. Use numbers in here that happen to be big. Subtract it as much as possible until we get a number that we can then generate using these bits. That makes sense. Oh wait, that actually makes sense. Oh, that's probably it. Erase that sort array. While target is less than or equal to 1 left at 35. That's probably it. That way, like, we can reduce this until it's something that we can feasibly generate. Thank God. Oh, thank fucking God we got that problem. Oh, that took way too long. Okay, now I have to get the brute force. Although it does seem like this problem is hard enough to where if I get the brute force, I'll be good enough. So let's do that. Let's get the brute force. Oh, that took way too long. That took way too long. That problem took way too long. All right. Question is, how do I brute force this like properly? Weight is less than or equal to 3. Oh, I accidentally wrote them in the wrong file or something. Okay, whatever, that's okay. Let's have a copy input format for this, just so I have it here. NW blah blah blah, or NT, something like this. And weights, yeah, we do need to read the array. There we go. Okay. Whatever, NW and then weights. NW. Brute force. Okay, so we need to show that. Or we need to like be able to just generate this efficiently. That's pretty much it. Yeah, we need to generate all the string. Well, generate all the strings, but more importantly, have them like sorted by their bucket, or like whatever their buckets are. Yeah, or like whatever the bucket is. So it's like we need to store the string as well as like the order. Okay. Well, 3 to the power of 10 is okay. Yeah, 3 to the power of 10 is completely fine. But we just need to limit it to small enough to where like it's easy to brute force. It was like it's easy to find like the shortest distance. The only problem is like, because it could sum up to potentially, the sum is up to, okay, so one combination can have up to 9 divided by 6, 9 factorial over 6 over 6 over 6. This is about n cubed is sketch, but n squared definitely works. Or n squared log n. So I will probably just do the n squared log n version. There's probably like a little more states to account for, but probably not too many more. Probably enough to like, probably enough for it to be okay, is what I'm saying. Stack, okay, so we do the top of the stack is like that current thing. As 0, 1, 2, pog. Shit. What are we doing here? I just feel myself getting more and more lost the more I think about this. Gen. I'm writing it a separate method. Public static array list string gen. So we need to do an array deck of string of nodes. My bad. Just initialize the new node. Essentially an empty string. An empty string is a valid string, so we just do array list string. Array list more specifically hash set. If cur.stack.length is greater than 0, then we pop string next is equal to cur.stack.substring 1. Take it from here. Yeah, because let's add it to the. Actually, it's better if we just remove it from the back. Cur.stack.length minus 1. That's it, minus 1. Last element is head. Then we do if scene.add next, because this is a BFS. Yike. Struct. IDs.add 0. Because when I do zeros, IDs occur. No. IDs.pull. Put, we do scene. Scene.add this, whatever the fuck that is. Okay, that's all initial stuff. And so if this is a new thing, stack.length -1 minus this. Adding is way easier. Yikes. Is IDs even doing anything? Why do I feel like IDs is doing nothing? Like IDs is unironically doing nothing. IDs is like, is it literally doing anything? I can only make it do something if I do this. The scene that contains key. Yeah, first increase it and then we do next, which is the string itself. Goof is like the ID. And then what we want to do is we want to do edge input. Yeah, because these are the edges that have a length of 1 between them. So we can do like BFS, basically. Input next. No, boof. Boof is like the new ID. Or I guess scene.get next. If scene.contains key, edge and put that at ID. Lamella stack. Oh, yikes. I have seen. This idea was just used, so when proof increases by 1. When proof increases by 1, we want to do string size of proof. So we do this, and then we return key, or return res. So res contains all of these in order, and we also have the edges themselves. This is good. This is really good, because this is really important to have. Patterns.length. Oh, wait, not. Hold on. Not. These are supposed to be not. That number makes a lot more sense. I don't know about you, but that number makes a lot more sense. Alright, let's just print some random things out. Like pattern 20, pattern 69, doesn't even matter. 510, do 0, and then the last one like 40. I just want to like see if it's like, if it makes sense or not. These make sense. These make sense. These make sense. Okay, these actually make sense. Okay. It's n squared, so we do so we can do edges. No, we can't. Stupid. New array tag at integer. We do edges at. Yeah, because it is bidirectional. Although I don't know whether this is actually necessary or not, because it might cause duplicate edges. But it will make it incorrect. I'm just gonna comment out for now. If I need it later, I can just comment back in. Actually, I'll just keep it in for now. So we can do something like, I don't know, for more like for here, and then it's up to 10. This value itself could be up to 20. We don't want to make it too big, but the thing is, like, there's this many possible things. We want to find the distance from here to here. if we no, because then it's like it's possible we could just put a 1 on the top, and if we need to remove one again, we just remove it. We don't. There's not we can move this and then remove that. It's not always possible. It's like this. That's why we need to brute force it like this. Yeah, this brute force is not trivial. I think it's a problem here. This brute force is not trivial. We need to know which one it is. I can turn all of these sequence paths using a key. That's not a problem. That itself is not a problem. Okay, so we can use a queue for that, not a problem. Or just BFS. And then we need to figure out for each possible state you can emerge from. It's like if you're on the state and we want to get to something in here, what is the nearest thing with that type of color? Or like with that type of configuration. Node B is the closest node to A, so that the frequency of B is equal to X, Y, and 0. Okay. And we do the BFS. Is that the only thing that we care about? I think so, actually, right? There's only like 27 that we need to check. Like 27 of these, essentially, but we just store more than that anyway, because it's not like it really matters. It's still going to be enough memory. Because there's K nodes and like roughly 150 templates. Not 150, but 330, 400, let's just do 400. Raise off of best at I is equal to -1. Best at I, the type of frequency of I is 0. So for int I is equal to 0. This is the node that we start from. Yeah. This is like the nodes. These are the nodes that we start from. So then we can just do array deck. Array deck. is equal to 0. While q.size is greater than 0, we got it. Q.pull, we do for next, and edges occur. If distance at I from I to next is equal to -1, because like everything is at a trade 1, it's a BFS. Distance at I occur plus 1, and then we do so if best from starting from I, the frequency at next is equal to -1, then best at I, the frequency at next is just next, and then get the distance itself is like easy. Q to add next, so we update this, we update best, and then we add it into the queue. I think that's it. Like that's literally it. And we can visit all other states like this, because we can always reduce 0 and then we can always just build it up. Okay, cool. We have distances and we have best. dp is equal to Newton K. dp so dp at 0 is equal to 0. Well, like we start from nothing, right? And we arrive at something. Sure. Yeah, we always want to gen like all possibilities, I think. And these are ordered in like increasing like distance or whatever. These are ordered by increasing distance. So if you do dp of like the current of k, where k is like the current string, what is the min like distance the min requirement we need to get to k? Among k, there's like a bunch of possible things that we could come from earlier, which we need to process properly as well. I don't think best is useful at all, actually. I think we literally just need to store the buckets themselves, and then we just like directly get them from that. It's also better memory anyway. Is it frequent? Well, frequencies, because it's like the ID. So what nodes have this type of frequency? We just do this. Public and ID, which is like a type of node. Public and unit array list. So we need to add a new unit where this is the ID, the distance, ID distance, yeah. So int t is equal to 0, t and t plus plus. So counts at I, or counts at key is equal to well, for it, wait, the lamel is equal to 1. Lamel is equal to 1. Lamel weights of W times key. Okay. And then why is this? Oh, because weight's at T at W. Nice. There we go. And so key is something that we've gotten already. Next is equal to new array list at unit. For unit U and DP. For int paths buckets at key. New unit patterns, which is like the pattern itself. The pattern itself, and as well as, well, we generate a distance, which is a distance from u.id up to the pattern itself. Next I add UU, OU, NU, RU, Pokemon. Anyways, EP becomes next. And at the very end, res is equal to integer.max value over 2 for unit U and DP res and U dot, what is it? U dot moves. I'm gonna nut if this works on first try. Sad. Hold on. Okay, it took a while, but it did print W, so. I'm stupid. I should be using a fucking hash map for this. Why the fuck do I need unit? It's literally just straight up exponential if I didn't do that. Oh my god. DP output 0, 0. For in key DP out key set. do something that's like or an cur buckets at key or something like that. Unit u is or not even unit, but just like distance is equal to it's equal to the dp.getPar plus distance from the parent to this current node. So if next that contains, if we don't contain the key cur or the value stored in cur is strictly greater than d, next dot put cur in d. For int k dp.keyset dp.getK. 3712. No, but it is. These are simple enough test cases to where I could probably reasonably debug it. I think it. Because a lot of it is pre-comp, so that's something that's worth noting. Patterns. That means it took that much distance. Key. One, two, one. Wait, we need to put one weight. We need to put another weight, and then we remove a weight. Oh, do we need to empty the stack at the end? We just leave it empty. Okay, that's. I did not realize that was a thing. I did not realize that was a thing. Res plus equal to weight set minus 1 W. Please don't TLE. I think it's a situation where I would rather prefer a wrong answer than TLE. This is also going to take a while to run, so. Okay, we got this. We got the brute force. Okay, we got the. Okay, we did properly do the brute force, so. Assuming we don't FST anything, I think this means we made it. But man, this was such a bad contest for, like, for how well I should have done. Like, I definitely spent way too long on the second problem. I just did not think about it properly. But you know what? That's okay. It's better than nothing. Okay, I'm it's pretty late and I'm honestly a little tired. I think we're just gonna just stop here for now. So yeah. Um hopefully I don't hopefully I made round two. Like judging by the performance, it seems like I did, but just cross our fingers and hope that we did. Yeah. See ya.